There's lines, lots of lines, just need 2 points to form a line. Yeah, lines, lots of lines, or a point and so is fine. Yeah, we've got horizontal lines. Whose equation is just y equals a number of vertical lines. Whose equation is just x equals a number of rising lines. And slope that's positive, falling lines, and slope that's negative. Parallel lines have exact same slopes. They're also called inconsistent lines. They'll never intersect. The lines with the same slope y intersect their dependent lines. They coincide. The perpendicular lines have negative reciprocal slopes across one single xy plane. And now that you mention the xy plane, the x-axis is a horizontal line. It doesn't have slope, so y equals 0. The y-axis is a vertical line. X equals 0, slope is undefined.
Well, hello again, Algebra 1 students. We are here with 4.3 on Big Ideas, titled Writing Equations of Parallel and Perpendicular Lines. So our focus in this lesson is still linear functions, looking at linear equations, but now our focus here, though, is parallel and perpendicular lines. And so we'll see, we'll take the first half looking at parallel lines, and then the second half of the lesson will be looking at perpendicular lines, or parallel kind of and perpendicular as well in that second half. But first, let's go into our cartoon for the beginning of this. It's in the bleachers. It's a operating room. Doctor says, "Suture, let's move it. We're losing him." And he looks up. "Wait, the game is tied with 5 seconds left. LeBron has the ball." So he gets a little distracted there at the end. Yeah, so they may have lost the patient. All right, moving into looking at parallel lines. There's just one main thing we need to understand about parallel lines, is that they have the same slope. You have that right there in your core concepts for parallel lines. Right there in your notes, you want to maybe highlight that they have the same slope. It says all vertical lines are parallel. But the main thing is that the lines have the same slope. So whether you're looking at the lines and you're seeing their rise and their run, or you're looking at the change in the y or the change in x, or you're just looking at the slope-intercept form and you notice what the m is, if they are the same, then they're parallel lines. Also, as you can see from this, it says they never intersect. Parallel lines will never intersect. So that's something that's always true about parallel lines. Not just vertical lines are parallel, but all horizontal lines are parallel as well. Okay, so we start on the top of page 109 looking at this extra practice, just starting with 1 and 2. So these two are going to be like the same thing. I'm going to go ahead and do number 1, and then you can pause the video and then try 2 on your own. That's kind of what we're going to do here for this lesson. I'll do one, you'll do another, and then check your answer on that second one. So for this first one, it's asking us, well, for 1 through 6, really, it's asking us the same thing. Determine which lines, if any, are parallel. And so this one gives us the picture on the graph. So this is what we are shown. And so we want to find the slopes. This is how we would do this. We would just identify the slopes of all 3 lines. Lines are labeled A, B, and C. So I'm going to start off with line A. Find the slope for that one. So it's just a rise over run. So your rise here is going to be 3 units, as you can see there. So the rise is 3 and the run is just 1 unit. So it's a 3 over 1, which gives you a 3 for the slope on A. For B, line B, our rise on that one is 4 units. As you can see, we're going up 4 units. And then the run is 1 unit over. So 4 over 1 is going to give us 4. So B's slope is 4. And then for C, our rise here on this one is also 4. And the run is also 1. And so it has the same slope as B. So B and C both have the same slope. And the definition of parallel lines is that they have the same slopes. So B and C are parallel because they have the same slope. All right, go ahead and pause the video now and just do the same thing for A, B, and C. Which lines are parallel out of these 3? And then check your answer. All right, so if we got 2 finished and we want to look at this one. So we start with the slope on A. As you can see there, it would be, you're going to rise 4 and run left 2. So that's going to be a 4 over negative 2, which is a negative 2 slope for A. And then for B, we can go this way, you can go down 3, actually go down 2.5, really that's what you're doing, going down 2.5 and then over 1. So that's like, 2.5. Negative 2.5 over 1 is a negative 2.5 slope. And then for C, this one's you're going to rise 2, go left 1. And so that's going to be 2 over negative 1, giving us negative 2. So you can see both A and C have the same slope, so A and C are parallel. Those are the ones that are parallel. Now there might not be any that are parallel. You might have gotten a negative 3 slope for this one perhaps, and then none of them would have been parallel. That's possible. All right, let's move on to the next couple. All right, so number 3 and 4, on these ones we're given the 3 lines now with just 2 ordered pairs given to us, so we have to find the slope using our slope formula between those 2 points where we subtract the y's and we're subtracting the x's. So let's do number 3. We'll do 3 together. You can try number 4. So first with number 3, line A, we're going to be looking for the slope. So you're going to subtract the y's on top. It's a negative 1 first. On the first y, I always like to start with the first point. So the first y minus, don't forget the minus because we're subtracting these points, minus the second y, which is 2. And then the bottom is the x's, so the first x. Remember, you always start with the same point. We're starting with the first one for y, we have to start with the first one for x. So negative 4 minus the second x, which is 2. And then we just go ahead and subtract on both of these. We have negative 3 on top, negative 6 on the bottom. And so that's going to give us negative over negative. Positive 3 over 6 is going to give us a positive 1/2. So there's our slope for A. B, we'll do the same thing. Start with the first y, negative 3 minus a 1. That's what's going to be there, negative 3 minus a 1. And then the bottom is the x's. So x is negative 5 minus a 5. So negative 3 minus a 5. And we're going to get negative 4 on the top, negative 10 on the bottom. So again, negative over negative is a positive, and 4/10. You're going to reduce it by 2. That's going to give us a positive 2/5. So far we know that A and B are not parallel. They're not the same slope. So let's check line C. So the slope here, starting with the first y, negative 3 minus negative 1. Negative 3 minus, not negative 1. Negative 3 minus, oops, I'm doing this wrong here. Negative 3 minus, this should be a negative 1 here. I think I did it wrong on this one. And I did. Look at that. So that one, am incorrect. So I'm going to have to come back and redo this one. Hold on. Alright, so let's go ahead and start with C again. Let's try this again. So that's a good example that you do need to be careful. You can very easily mix up these numbers sometimes. So again, y is on top. Negative 3 should be with the negative 1. Those are both the y's. So negative 3 minus a negative 1. And since that's a double negative, we'll change that to positive up there. And then the first x is negative 2. So negative 2, and then minus, and then it's going to be the second x is 2. And now, as we see, we're going to subtract here, get negative 2 on top, and negative 4 on the bottom. And negative over negative is positive. 2/4 is a half. And so that matches the slope of A. So that means that A and C are parallel lines. So A and C are parallel. All right, go ahead and pause the video, do the same thing for 4, and see if you can find any parallel lines out of these 3 A, B, and C lines. All right, so hopefully you've finished number 4, and you found your answer on this one. Let's see on A, what the slope should be is negative 1. After you do subtracting the y's over subtracting the x's, you're going to get a negative 1 slope for A. On B, the slope is a 1/7. And so that one is not the same as A, so A and B are not parallel. And then C, the slope on this one is a negative 2. After you subtract y's over subtracting x's, you get a double negative up on top here, so it's like 4 minus negative 6. 4 minus the negative 6 there, and so double negative makes that 10 on top. Gives you a negative 2 for the slope. So there's no lines that are parallel, no same slope, they're all different slopes. So you just say none parallel. Or no parallel lines or something like that. Alright, moving on to number 5. This one, instead of giving us the picture of the graph, instead of giving us just the points, it gives us the equation of the line. And so the best way to do this is to set these equations into the slope-intercept form, y equals mx plus b form, so that we can identify the m, the slope. And so that's what we want to do here for A. The first thing I want to do is get the y term by itself, which is over here, negative 3y. I need to move the 9 over the other side, so I'm going to subtract 9. So we start with A, we're going to first subtract 9 from both sides. So I would cancel the 9's here. And I'm going to put the negative 3y first, and then behind that the 4x minus 9 on the other side. And now I just need to divide everything here by negative 3 to get y by itself. So there's 3 terms. That's the one with the y, the one with the x, and the 9. All are going to get divided by negative 3. And so as we simplify there, now these will cancel because they're the same thing over itself. So y is by itself here. We're going to get a 4 over negative 3, or a negative 4/3 x. And then this one, it really doesn't matter for your last one because we're just really concerned about the number in front of x here, the slope number. But the last one would simplify to a positive 3. So there's our y equals mx plus b, so we can identify our m is a negative 4/3. Alright, so now going on to b. Looking at the equation for b, y is here, it's 8y, so the only thing I need to do is divide everything here, all 3 terms, just like I was doing with the negative 3 here, but this one by 8. So if we divide by 8 there, it's going to cancel it out, and divide the negative 6 by an 8, and divide the 16 by an 8. And so that will give us, as we cancel them out, negative 3/4. I should have put an x here, so I'm making a few mistakes here on my thing. Should have had an x. So negative 3/4 x plus 2. I'll come back at the end, hopefully remember to put that in there. But our slope is that negative 3/4. Okay, so that's not the same slope as we're getting for the a. These are not parallel, so a and b are not parallel. Let's move on to c and check this one out. C is very similar to b, where we're just going to divide everything by 4 first to get the y by itself. So divide the 4y by 4, it cancels it out, leaves y by itself. And then the negative 3x, that gets divided by 4, and the 9 gets divided by 4. So that now gives us y is equal to negative 3/4 x plus the 9. So our slope there is negative 3/4, which is the same slope as b. So for this one, we see that b and c are the parallel lines. They have the same slopes. All right, go ahead and pause the video now and try number 6 the same way. Get these into slope-intercept form, and then you can check their slopes. Alright, so hopefully you finished number 6 now and you see which ones are parallel. And so on A, for that one, we would need to move the x over first. So I'm going to first add x to both sides to get just the 5y by itself. And so that leaves me with a 5y is equal to x plus 4. And then we just need to divide everything by 5. So we do that. And so that leaves us with a y by itself. This is a 1 over 5, a 1x over 5. So 1/5 would be the slope for this one. And then you got the 4/5 here. But the 1/5 is the one you're looking at. For B, this one's already kind of just ready to go, just to divide everything by 5. So we want to divide everything by 5 on this one. We get the same thing going on here with a 1 in front of x, 1/5 in front of x there. So y is equal to 1/5 x plus 7/5. And so C, obviously A and B we can see are parallel. They both have the same slope. We can check C and see does it all 3 of them parallel line. That's possible. So we would first want to add the 2x to move that over to get the 5y by itself. And so for C we got 5y equals 2x plus 5. And now we divide everything by 5 and we would end up with a 2/5 x. So this one is not. So A and B are the only ones parallel on that one. That should have been your answer for number 6. All right, let's move on to 7 and 8, which are a little bit different. All right, so 7 and 8 ask you to write an equation of the line that passes through the given point and is parallel to the given line. So we have a point that's given to us, an ordered pair, and then an equation. So we're going to use, just like we learned in the last lesson, the point slope formula right here, or the point slope equation, where we're going to put in our ordered pair. The x and the y numbers go in where x1 and y1 are, and then we're going to put in a slope. And so what slope do we use? Well, since it says parallel right here, we need to use the same slope. We need to use the same slope as the line is here. So we need to identify what the slope is of our line here and use that slope. So our slope right there is a 1/3. That's the slope we're going to use with this ordered pair to write an equation. And so we start off with y minus, just using this form here, y minus, and then the y number, it's always y minus y number here, is -1. And so since it's double negative there, we're going to turn that to positive and plus, and then it's going to equal the slope times the x minus the x1. So x minus, and then the x point is 3. And then we close our parenthesis. And so there's our point-slope formula, but we want to always get our answer in slope-intercept form. That's always usually the best. So what we're going to do here is distribute the 1/3. And so we're going to see y plus 1 is equal to, and that's going to get 1/3 x. We're going to give 1/3 to the x, multiply 1/3 times 3. That's going to be a minus 1, because 3 and 3 will cross-cancel, leaving us just with a 1. And so now the last thing, to just get y by itself, subtract 1 from both sides. And so we'll do that, and that gives us a -2 now. So y is equal to the 1/3 x minus 2. And so you can see the 1/3 is still the same slope as what we have here. All right, you're going to do the same thing for number 8. Do it the same way. Use the same slope, use this point, and write an equation in simplest form, in the slope-intercept form. But start with using this form here to get it to this form, and then go from that form to slope-intercept. All right, go ahead and pause the video and do that number 8. Alright, hopefully you're finished now, number 8. So here's what we should be looking at. There's our ordered pairs. There's our slope, -2. And so we start plugging it into this formula, we get this. And so it's going to be, since your y is a negative, you have a double negative, turn that to positive, and then -2 times x minus 1 over here. And so now we just need to change that to slope-intercept. So we're going to distribute the 2, with that -2. So y plus 2 is equal to -2x plus 2 when I distribute -2 into those two. And then just subtract 2 from both sides. So when we subtract 2, we're going to see y is equal to, this is going to cancel out here, so we're not going to have any b. It's just going to be y is equal to -2x. So since we get a 0 here, we don't need to put plus 0 at the end. Simplest way would just be to say y is equal to -2x, and it does have the same slope as what we have up here. Alright, here's our joke of the day. It says, how can you drop a raw egg onto a concrete floor without cracking it? Well, the answer to that question is any way you want. Concrete floors are very hard to crack. Hopefully you got that joke. Alright, move on. Let's go on to perpendicular lines now. So looking at perpendicular. So perpendicular lines so parallel lines have the same slope, perpendicular lines have two parts to their slope. And it says negative, I like to say opposite sign. So the two parts are that it's opposite and that it's a reciprocal, opposite and reciprocal. So they are opposites and reciprocals of each other. So if we look at these two, the blue one and the red one, you can see here's your slope here on the blue one is -2, slope on the red one's 1/2. So they are opposite signs, one's positive, one's negative. And they're also reciprocals of each other. So it means reciprocal just means if you flip the fraction upside down. If I flip 1/2 upside down, I get 2 over 1, which is the same thing as a 2. And so they are reciprocals of each other. So that's the two parts to looking at perpendicular lines. Everything else is pretty much the same. So if we identify it's not the same slope, it's an opposite reciprocal slope, that's what we would use if we're going to write the equation. And that's what we're looking for to identify perpendicular lines, is that their slopes are opposite and reciprocal. Another idea is you could multiply these two slopes, -2 times 1/2, and that would give you a -1. So if you can multiply the two slopes and get -1, that also verifies that they're perpendicular. Perpendicular is where they connect at a right angle right here. So they make a 90-degree angle at the connection point. Alright, let's try a couple now on this one. Alright, so we start with the ones that have pictures of the graphs drawn on our coordinate plane. So there's 3 lines here. See, it's an A, B, and C again. So A is the dark one, and B is this one going across this way. C is a very light one going this way. And so we're looking to see, determine which of the lines, if any, are parallel or perpendicular. Okay, so now we're not just looking for perpendicular. We're looking for whether they could be parallel or perpendicular. So that's what we're checking out here. Now, obviously, the A and the C, those ones we want to check to see if they are parallel. And then B, we want to check to see if B is perpendicular to either A or C. That's kind of what we're looking for. But to do that, we just need to find the slopes. Same thing as we saw before. We just need to identify the slopes using rise or run. So letter A. So A is the dark one right here. So our rise on this one is 4 units. So it's going to go up 4, and then it's going to run to the left 2. It's a -2 units that way. So that gives us a -2 for the slope for line A. For line B, that's going this direction here, our slope starts with the rise. We're going to rise 2, and it's a +2, and run in the positive direction 2. So 2 over 2 is going to give us 1. And then let's find out what line C is here. So line C, that's going to start with a rise of 2, and then a run of -1, going left 1. And that's going to give us a -2. So as we compare these, we can definitely see that A and C have the same slope. They're parallel. And B is not perpendicular to either one of those. In order for B to have been perpendicular, it would have to be a 1/2 slope. Positive 1/2 slope. If B was that, then it would be perpendicular to those two. So all we can say here on this one is that A and C are parallel, and then we move on. So go ahead and pause the video, do the same thing for number 10, see if you can find any of the lines that are parallel or perpendicular. Alright, so right there on the top of page 110 we are looking at number 10, and we start off with just looking at our slopes. For A, the A slope would be a rise of 6, run of 2, it's a 3 for that slope. B would be rise would be going down 2 and then right 6, that's going to be a -1/3. And then for C, it's going to be a rise of 5, run of 2, 5 halves. So there's nothing that's the same, so no parallel lines, but these two are interesting right here. They are opposite signs and they are reciprocals of each other, because if you flip 1/3 upside down, you're going to get 3 over 1, which is the same as a 3. So opposite reciprocal for A and B, so that tells you that A and B are perpendicular. So that's all we could say for 10, is that A and B are perpendicular. So you got to be paying attention, not just the same slope, but opposite reciprocal slopes is also what we're looking for to identify perpendicular lines. Alright, now looking at 11 and 12, now we got the points here on this one. Again, we're trying to see if there's any parallel or perpendicular lines. So we got to do the same thing, identify slopes, subtract the y's over subtracting the x's. So we start with line A first. So that's going to be our 4 minus a 1 on top. I'm subtracting y's, and then -2 minus 1 on the bottom. And so it's going to give us a 3 on the top and a -3 on the bottom. So that's going to give us a -1 for a slope on A. So line A's slope is 1, or -1. For B, we're going to do 1 minus 4 on the top. For our subtracting our y's, subtracting x's is 2 minus 4. So 2 minus 4 on the bottom. And so it's going to give us -3 on the top, -2 on the bottom. And it's a +3 over 2. Just leave it as an improper fraction. That's fine. And then for C, -2 minus a 4 for our top. And then for the bottom is a 1 minus -1, which will be a double negative there, so we're going to turn that bottom one to positive. And so that's going to give us -6 on top and 2 on the bottom. And so that's going to reduce down to a -3. And so if we compare the slopes now at this point, I don't see anything that's the same, so there's no parallel lines. Let's look for ones that are opposites. So this 3 over 2 is opposite of either one of these, but it's not the reciprocal. So the reciprocal of 3 over 2 would be 2/3. So there's no opposite reciprocal ones either. So for this one, there are none that are parallel or perpendicular. So neither is that one. So go ahead and do the same thing for 12. Go ahead and pause the video and identify the slopes for all of them, and then compare them, see if you can find any parallel or perpendicular lines. Alright, so hopefully you got your slopes here. So A, the slope for A you should have got was 3. After you subtracted the y's over the x's, you got a couple double negatives in that one. Slope for B was 3 also. So right away you got parallel ones for A and B. And then the slope for C is a -1/2. So that's definitely not going to be perpendicular. It's the opposite, but it's not reciprocal. If it was a -1/3, then it would be a perpendicular to both of those. So the only thing you could say for this one is that A and B are parallel. So hopefully you identified that. That's all you need to do for this one. Identifying that would be the correct answer. Alright, moving on to number 13. Now they're showing us the equations again. Best to keep it in y equals mx plus b. So our first one, A, is already there. We can just identify the slope there. On that one, it's 3/4. So our slope for A is 3/4. But for both B and C, we're going to need to adjust them a little bit to get it in y equals mx plus b form first. So for b, what we're going to do there is we're going to divide every term here, all three terms, by a negative 3. So divide by negative 3 on that first one, 4 divided by negative 3, negative 3 divided by negative 3. And so when we do that, we get y by itself, negative 4/3 here, and this will be a positive 1. And so that's what we get. Y is equal to negative 4/3 x plus 1, and so then we just do that. Negative 4/3 is the slope. And then we come to c. We're going to divide every one here by 4. So divide by 4 on the first one, negative 3 divided by 4, and then 9 is divided by 4. So that gives us y first, then negative 3/4 x, and then just a 9/4. And so there's our slope-intercept form. We can identify the slope there as a negative 3/4. So now as we compare these three, this is a negative 4/3, and that's opposite reciprocal than the a, which is a positive 3/4. So a and c over here in green, they're not the same slope because they're opposite signs. They're the same number but opposite signs. And then these ones are reciprocals, but they're the same signs, so there's nothing with those two. It's a and b here that are perpendicular because they're opposites, positive, and this one's negative, and they're reciprocals of each other. If you flip 3/4 upside down, you get 4/3. And so we can say right there, those are the two ones we want to notice are opposite and reciprocal, so a and b are perpendicular. Go ahead and do the same thing on 14. Identify which ones, if any, are parallel or perpendicular of those lines. Alright, so hopefully you got an answer for this one. Let's go ahead and check to see if you're correct. So for line A, this one we're going to need to first bring that 2x to the other side, adjust it a little bit here. So if I do that, I'm going to get 5y on one side, 2x is now going to be over here with the 1, 2x plus 1, and then just divide everything there by 5, and so that gives us y is equal to 2/5 x plus a 1/5. So 2/5 is the slope for 14. And then for line B, we actually can see the slope right here is 5/2, and for line C, we could see the slope is a 2/5. So you're already able to see those. So you can see on this one, as you compare these three slopes, 2/5 is the same as 2/5 on C. So A and C are definitely parallel. This is a reciprocal. 5/2 is a reciprocal of 2/5, but it's not the opposite sign. It has to be both opposite and reciprocal to be perpendicular. If this was a negative 5/2, then we could have said it's perpendicular to those two. So all you can say on this one is that A and C are parallel. That's all you can say. Alright, let's move on to our last couple problems. Alright, so again we come to ones where we're going to write the equation of a line that passes through the given point, but this time it's perpendicular to the given line, not parallel. It's telling us perpendicular. So be very careful as you read these. Make sure you understand which word you're looking for. This one's perpendicular. So we're still going to use the point slope on a formula here, and we're going to use this point, but which slope do we use? We don't use the slope that we see, because that would be parallel. Instead, we need to use the perpendicular slope, which means we're going to use the opposite reciprocal slope. So we need to figure out, okay, what opposite reciprocal of 2/3? Opposite would be a negative slope, and the reciprocal would be 3/2. So we need to use a negative 3/2 slope for this one. This is our ordered pair, and this is our slope to plug into our formula. So we start with y minus, and then it's the y point right here, the y number, which is 2. And then it's equal to the slope we're using here, the negative 3/2, times the x minus the x point. So x minus, and our x point's negative 2, so we fill in negative 2, close the parenthesis. We do have a double negative right here, so we're going to turn that to positive. And so there's our equation in this form, but we always want to get it into slope-intercept. That's how we want to leave our answer. So I'm going to distribute the negative 3/2. So we'll start off with y minus 2 is equal to the negative 3/2x, and then we're going to see negative 3/2 times 2 is going to cross-cancel our 2's and leave us just with that minus 3. So the last thing to do is just to be adding 2 to both sides. And so as we add 2, we're going to get a negative 1 now. So y is equal to negative 3/2x minus 1. And so now we can see from this slope, 2/3, this is the opposite reciprocal slope is here on this equation. Alright, go ahead and try the same thing on number 16. Use this point and use the opposite reciprocal slope. Now the first thing you're going to need to do here, and maybe I'll help you with this one, since this is not in y equals mx plus b like 15 was, we're going to have to adjust this a little bit. You're going to need to just divide everything here by 2. So each term gets divided by 2, so that leaves you with just y. 4 over 2 is a 2x, and then you can just say minus 3 over 2. So you can get that equation there. So I'll start you there. Go ahead and write the equation now that's perpendicular to this equation here. Alright, so hopefully you paused the video and you got an answer for me on 16. So we're going to use this ordered pair, plugging it into this one. Our slope first that we're going to use is opposite reciprocal of 2. So it's going to be a negative, and it's got to be, this is like 2 over 1. If you flip 2 over 1 upside down, it's a 1/2. So negative 1/2 was the slope that you needed to use. If you didn't use that, then that would be incorrect. So as we plug this in, we're starting with y minus the y point, which is 1, and then the slope, the negative 1/2 we're using, and x minus the x point, which is 3 from our given point. And again, that's our equation in point slope form, but we want to get it in slope intercept, so we're going to distribute this negative 1/2 here. So y minus 1 is equal to the negative 1/2 x, and then negative times negative is a positive, and then half times 3 is a 3 over 2. Because it's like 3 over 1, 1 times 3 is 3 on the top, 2 times 1 is 2 on the bottom. And the last thing to do is just to add 1 to both sides. And so as we add 1 to both sides, we're adding 1 to 3 over 2. That's like 2 over 2 added to this. That should be 5 over 2 now at the end. So y is equal to negative 1/2 x plus a 5 over 2. Because as we add this 1, 3 over 2, 2 over 2 is the same thing as 1, like I said. So 3 plus 2 is 5 for the top. Alright, so that concludes our lesson here on parallel perpendicular lines. Hopefully you guys understand how to find and identify these parallel and perpendicular lines from this lesson. Alright, I guess I'll see you on the next one. Have a great day, everyone.